Hi, so we're going to look in this video at another form of indirect proof. This time it is proof by the contrapositive. So contradiction is quite easy to understand because it's very easy to make a contradictory statement. Contrapositive can be a bit more abstract. It is a sentence or statement which means the same. It's just phrased a different way. So for example, what I've done is, this number is even. A contradiction to that would be, this number is odd. But the contrapositive to this number is even is, this number is not odd. Okay? I am better than you. That sounds really arrogant now that I've said, now that I've realised. I am better. I'm not meaning this to anyone watching the video. I am better than you. The contradiction of that would be, I am not better than you. Whereas the contrapositive is, I am not worse than you. Doesn't sound any less arrogant. Okay, so what can be confusing is necessarily what the contrapositive statement is. So we're going to find the contrapositive statement and then prove that. It can be useful to do this because sometimes it is easier to prove the contrapositive rather than the direct statement. Okay? So example 1, prove that if 5x plus 3 is even, then x is odd. So what is the contrapositive statement? So 5x plus 3 is not even, x is not odd. It's not a very elegant way of describing it, so another way we could phrase it. So I've rephrased it as, if 5x plus 3 is odd, x is even. So now we understand our number theory, we can hopefully find and prove this. Okay? So there exists a value of k in the natural numbers such that x equals 2k. So there's a new symbol there, maybe if you've never seen it before. That backwards capital E stands for there exists. So all we need to find out is that there exists a number, a natural number, k. Sorry, I stopped writing. So there exists k, a natural number k, such that x equals 2k, as in it is even. So let's see what happens when we substitute that in. So now we have a situation where 10k plus 3, okay? So then let's try and see what happens if we can change that, okay? Now hopefully what you can see is that is the general term for an odd number. Therefore, 5x plus 3 is odd. So we've proven the contrapositive, which therefore means that if 5x plus 3 is even, then x must be odd. So quite conceptual, and it'll take a while to maybe comprehend, but you'll get there. So example 2, prove that if x, for all x, y, in the set of natural numbers, prove that if x plus y is even, they're either both odd or both even. So firstly, let's get the contrapositive. So, not the most elegant way of describing that, but essentially if x plus y is odd, then one of x or y is even, and x or y is odd. So they must basically be different. Okay? So now we need to prove that. Does it matter whether I make x odd or make y odd? Not really, because it's going to have the same effect. So let's make x even, and let's make y odd. And then we do 2k plus 2k plus 1. Which gives us the general form of an odd number. Again, quite conceptual, but that is proof by contrapositive. Okay? One new symbol, I think, the backwards E, which is there exists. Okay, so proof by contrapositive.